Good morning, everyone. The concept of minor, cofactor, adjoint, and inverse. Okay, these are correlated. One after the other, you will be applying them everything into the inverse of a matrix. Now, let us understand how to find the adjoint of a square matrix. This is very easy, first of all. First, you are supposed to find the cofactor of a matrix. That is, the adjoint matrix is a transpose of a cofactor matrix. So it simply means that you'll have to find the cofactor of a matrix and then find the transpose of that cofactor. Okay, now if you remember the last question yesterday's class, the last question we solved was a 2 into 2 matrix where we solved the cofactor of it, and the cofactor of this matrix was 7, 3, minus 8 and 2. Okay, now to find adjoint of this matrix, okay, sorry, to find the adjoint of this matrix, first you have to find the cofactor and then again do the transpose of it. Now what do you mean by transpose? If the rows change to columns, that is called as transpose. So if you see here, the first row is 7 and 3, and if you see the adjoint, the first column is 7 and 3. The second row is minus 8 and 2 here, and the second column is minus 8 and 2. Okay, when we change the rows to columns, that is called as a transpose. And when we find the transpose of the cofactor, that is called as adjoint of a matrix. Did you understand? Okay, now let us go to the problem to solve it. Not sure if there are problems for adjoint. Okay, this directly inverse problem. Now, before going to the problem of adjoint, we will learn the inverse also. This is the last concept in matrix. So listen carefully. This is again very, very important for the examination. Compulsory question will come in your inverse, and the other one was Kramer's rule. Yeah, these two are very, very important. Okay, now listen. A square matrix B is said to be an inverse of matrix A if B into A and A into B is equal to I, where I is a identity matrix. Inverse of matrix A is denoted as A to the power minus 1. Okay, this is called as inverse of a matrix. We denote inverse of a matrix like this, capital A, or the name of the matrix. It has to be in the capital letter and the power should be minus 1. Okay, now when we will say it as an inverse matrix, when you multiply B into A matrix and A into B matrix, both the result should be an identity matrix. Okay, both the result, if it is identity matrix, what is identity matrix? Where your principal diagonal will be 1. Okay, if your principal diagonal is 1, this is called as an identity matrix. This is of 2 into 2. You can have of any form, 3 into 3, 4 into 4, any form you can have it. Okay, so this has to be proven. That is, B into A into B should be equal to an identity matrix. Now, inverse of a square matrix means the negative of the multiplicand or the multiplier matrix. One matrix can be inverse of another if the product of these two matrices are both in their alternate order. BA or AB results in an identity matrix. The same thing they are explaining it in the words. When you multiply B into A and A into B, it should be equal to an identity matrix. Okay, now for us instead of multiplying B into A into B, and then equating it to identity matrix, we have another formula which we will be using to find the inverse of a matrix. Okay, so for a square matrix, A transpose, A inverse is given as A inverse, A to the power minus 1. That is A inverse is equal to adjoint A. So if you remember, just now we understood what is adjoint A. Okay, so adjoint A divided by determinant of A. So we know how to find the determinant of A. It may be a 3 into 3 matrix or a 2 into 2 matrix. So we will have to find the adjoint A and then divide it by the determinant A. Okay, now adjoint A, how do you find? To find adjoint A, there is a formula which says cofactor of A transpose. So you have to find the cofactor transpose of get the adjoint. So to find the cofactor, you should find the minor. Are you getting the chain here? So to find the, let me write it. Yeah, let me write it here. Now to find the adjoint, you have to find the cofactor, right? To find the cofactor, in solving the cofactor, you will be finding the minor, correct? And we will be using adjoint to find the inverse of a matrix. So you see the link here. So you have to know minor, from that you have to calculate cofactor, from that you have to calculate adjoint, and then we will be using that to solve the inverse. Okay, and you know how to find determinant A. Though if it is a 2 into 2 matrix or a 3 into 3 matrix, you know how to solve the determinant A. Did you all understand? Okay. Now, by using this formula, adjoint A by determinant A, we will be calculating the A inverse. Now, again, there is one condition which we have to make sure that it is done. So, A inverse we can calculate only if determinant of A is not equal to 0. Okay, why it should not be equal to 0? Because anything when it is divided by 0, it will not give you a proper answer, it will show you error. So we cannot calculate A inverse if the determinant of A value is equal to 0. Okay, that is one condition you have to keep in mind. So when you calculate A determinant, first check if the value is 0 or any other number. It can be positive, it can be negative. There is no problem, but it should not be 0. Okay, so A inverse will only exist when determinant of A is not equal to 0. Okay, now there is another small concept under this known as singular and non-singular matrix. Now it is very simple here. If a square matrix, if you find the determinant value of a square matrix and the value of the determinant is 0, then such square matrix is called a singular matrix. Okay, when you find out the value of A, determinant A to be 0, it is called a singular matrix. If this determinant of a matrix is not equal to 0, it can be 2, 5, 10, minus 15, minus 80, minus 25, minus 30, plus 30, plus 100, anything else apart from 0, then it is called as non-singular matrix. Singular matrix means when determinant value is 0. Non-singular matrix means when determinant is not equal to 0. Are you all able to follow? Okay. Now, let us go to the problems. We will solve 2 into 2 matrix problem today. Okay. And then we will go for a 3 into 3 matrix. Listen carefully. I need full concentration here. Very, very important section C problem. They can ask this for 12 marks. Procedure is long. I'm saying it before. Procedure is long, but it is easy. If you have understood cofactor and minor, adjoint and inverse is easy. Okay, so let us start. So firstly, we will write down the formula. Okay, in the formula, that is A inverse. Now A inverse is adjoint A divided by determinant of A. So we are asked to find the A inverse of this matrix, that is a 2 into 2 matrix. Okay. Now, before finding A inverse, let us first find out determinant of A. So determinant A is equal to, convert this matrix into a determinant. So that will be 3, 4, 1, 2. Okay. Now, how do we find the value of this determinant? What should I do next? Can you say me what should I do next to find the value? Quick. Guys, we are solving 2 into 2 matrix. Multiple, what multiple? How do I find a value for determinant of a 2 into 2 matrix? What's wrong with you guys? How many problems have we solved? You don't know to say it's cross multiplication? Three into 2 minus 4 into 1. 3 2s are 6. Minus 4 1s are 4. 6 minus 4 is 2. So the determinant of A is 2. Now, since the determinant of A is not equal to 0, you have to find the value of A inverse. Now, next sentence you have to write down. Since determinant A is not equal to 0, A is a non-singular matrix. Now, when it is equal to 0, it is called a singular matrix. When it is not equal to 0, it is called a non-singular matrix. Every problem, it is compulsory to write this. Since A is not equal to 0, A is a non-singular matrix. Therefore, A inverse exists. Now, the next procedure, find the adjoint of A. Now, before finding adjoint of A, write the formula, which is nothing but cofactor of A transpose. If you just put 1 dash, it is transpose. If you put A to the power minus 1, it is called inverse. Now, before finding adjoint, we have to find the cofactor. So cofactor of A is equal to, what is the formula for cofactor of A? We have to find out -1 to the power of I plus j into find the minor ij. Okay, so this is how we find the cofactor. Now start finding cofactor for every element which is given in a 2 into 2 matrix. Cofactor of 3. This is the first one. So cofactor of 3, you have to find out -1. First find out the placement. Where is the placement? C, first row, first column, is equal to -1 to the power of first row plus first column. What is the minor of 3? What is the minor of 3? It's a 2 into 2 matrix. And we are finding the minor of 3. So the minor of 3 is 2. So -1, 1 plus 1 is 2 into 2. So 1 square, -1 square is 1. So the cofactor of 3 is 2. Correct? Now similarly, find the cofactor for others. Cofactor of 4. Now 4 is in first row, second column. Then -1 to the power of first row plus second column into minor. What is the minor of 4? Minor of 4 is 1. So -1 to the power 3 into 1. So -1 to the power 3 is -1 into 1 is still -1 only. Then cofactor of the next element is 1. That is, what is the placement? Second row, first column. So -1 to the power 2 plus 1. How did I get 2 plus 1? Second row, first column. Okay. Into, what is the minor of 1? 4. So -1 to the power 3 into 4. -1 to the power 3 is -1 into 4. So this will be -4. That will be the cofactor of 1. Now finally, cofactor of 2, that is second row, second column. So -1 to the power second row, second column. What is the minor of 2? 3. So -1 to the power 4 into 3. So -1 to the power 4 is +1. -1, if you have a positive power, it will be +1 into 3. So the cofactor will be 3. Now cofactor of A, that was the matrix A. Now the cofactor of matrix A will be 2, -1, -4 and 3. So this will be the cofactor of A. Now before finding adjoint, we have found the cofactor. Now if you find the transpose of a cofactor, that will become adjoint A. Now adjoint A is equal to cofactor, that is 2 minus 1 minus 4 and 3 transpose. Transpose means changing the rows into columns. So adjoint A is your first row here will become the first column. First row, that is 2 and minus 1, will become the first column, that is 2 and minus 1. And then again here minus 4 and 3, this will become the second column. First row will become the first column, second row will become the second column. 2 and minus 1, and then minus 4 and 3. This is the adjoint of a matrix A. Now finally we have adjoint of a matrix as well as determinant of a matrix. Now find out the inverse. A inverse is equal to adjoint A divided by determinant of A. Adjoint A is 2 minus 4 minus 1 and 3 divided by determinant of A was 2. Now divide the whole matrix by 2. 2 by 2, 4 by 2, 1 by 2, 3 by 2. Okay, every element will be divided by 2. So which is nothing but 2 by 2 minus 4 by 2 minus 1 by 2, 3 by 2. Okay, now the next step or the final step to find A inverse. 2 ones are 2 ones are 2 ones are 2 twos are, and then we cannot do anything with the other 2. So 1, you have minus 2, minus 1 by 2 and 3 by 2. This is the inverse of a matrix A. Understood? Somebody who gave me the inverse answer before? Was it Anusha or Bindushri who gave me the answer before? Cofactor is 12 minus 5. Check that once again. 12 minus 5. You have to get minus 5 and 3. How are you getting minus 12? You will not get minus 12 again. Please check. Yeah, Rajeshwari's answer is right. 12 minus 5 minus 5 and 3. Arpita and Anusha, check your answers once again. Sindhu, is that the final answer that you're giving me? 4 minus 5 by 3 and all? No, Sindhu, that's not the right answer. Check once again. 12 minus 5 minus 5, 3 is the cofactor answer. Correct. Correct. Now find the adjoint and find the inverse quickly. Twelve by 11 minus 5 by 11 minus 5 by 11 and 3 by 11. Very good. Correct. Twelve by 11 minus 5 by 11 minus 5 by 11 and 3 by 11. Correct answer, Kirti. Correct, Rakshita. So adjoint of B is cofactor of B transpose. That will be 12 minus 5, 12 minus 5 minus 5 and 3 transpose. So adjoint of B will be 12 minus 5 minus 5 and 3. So B transpose, sorry, inverse is equal to adjoint B divided by determinant of B, which is nothing but, I'll write it here, 12 minus 5 minus 5, 3 divided by 11. So 12 by 11 minus 5 by 11 minus 5 by 11 and 3 by 11. So this is the B inverse. No more doubts? Everybody understood? Okay. This problem will be your homework. You'll have to solve this and send. Tomorrow we will learn 3 into 3 matrix on an inverse. Clear? This problem and the problem which I gave yesterday, cofactors and minors, both has to be solved.